Good morning, this is Josh here at Mass Gun Works in frigid, cold, snowy, rural Indiana. Um, I was out here in my shop working on something and I wanted to take a minute and share it with y'all. So I had a customer bring me this really nice looking Winchester clone. This is a Puma brand lever action. And he was missing one of his screws. Okay, and this is kind of an important screw because there's a pin that holds the bolt to the lever, and the screw that goes in here holds that pin in place. There's a little hole here on the other side that you can use to push that pin out, and you want to keep this screw in there because if you don't, that pin could become dislodged in the process of using it, and then your bolt wouldn't operate right. So the game was the mystery screw because I didn't know what it looked like. I didn't even know what thread pitch it was. And by thread pitch, I mean how many threads, get this screw up here so you can see it, how many of these little threads are in an inch or in a millimeter. With a metric, it's going to be threads per millimeter. With a standard, it's going to be threads per inch. And with this being a foreign manufactured gun, could be a metric. So fortunately, my lathe that I use to make these things can cut metric threads. So here was the process. So I had to take my thread gauges, and a thread gauge is just a bunch of flat sheet metal pieces that have serrations cut in. And they're labeled, like this one right here says 27. This one right here says 24. And that just means that each one of these serrations represents a certain amount of threads per inch. So like this one's 27 threads per inch, and this one's 24 threads per inch. This one is metric, and it's, separated into metric. So you got 2 threads per millimeter, 1.75 threads per millimeter, 1.5 threads per millimeter, 1 thread per millimeter, and so on. They get smaller, smaller, smaller. So through the course of doing some testing with my thread gauges, I determined that it was either a 5 millimeter by 0.08 threads per millimeter. So the shaft of the bolt will be 5 millimeters wide, and then it'll have 0.8 threads per millimeter of length. Or it was a number 12 by 28. So I went to the hardware store because, it's easier to buy something like this than it is to just make it. It takes less time. But they don't sell number 12 screws. And the number 5, the 5 millimeter that I found, was almost the right size. I mean, like, it was close. So I knew I had a winner. So what I did next was I took my calipers and I measured. Okay, I got my measurement. It is 193 thousandths and 5/10 of a thousandth, so 193 and a half. And I have this chart here. Well, this chart has like every screw size known to man, metric and standard. And it tells me the size of the shank, and it also tells me the size of the bottom of the groove on the thread. Okay, so I'm going to pull you over here to the marker board. We're going to take a look at that real fast. So when you have threads, you have what's called a major and minor diameter. So your thread makes a V shape typically. Okay, so your major diameter is from here, and then if we have the other side to this peak, so it's from peak to peak. Okay, your minor diameter is from valley to valley. Excuse me, I got a little bit of stuff in my throat. Now, I had a feeling that this was 28 threads per inch, so I know that 28 threads per inch, this value here, the double depth of my thread is 46 thousandths. Okay, and I say double depth because you have, when you're measuring a circle, if you take material off of one side, it's going to come off the other. You can't really do like half a measurement. That's a whole different thing, and I can explain that later. But anyways, it's 46 thousandths. So I know that this groove total is 46 thousandths deep. So I did a little bit more math, and I came up with the fact that this screw, since I'm probably going to have to make it, get the glare out so I can show this drawing, is going to have to be 200 thousandths wide, and I need to have it 1/4 of an inch or 250 thousandths tall, and it's either going to be a 27 or a 28 thread per inch. So essentially I was going to start with the 28, and if that didn't fit, I was going to go to the 27. And the head of it needed to be 220 thousandths across, okay? So, bought a piece of metal, thank you, my local Lowe's, and got on the lathe. Here's what we came up with. See that tiny little booger? And it's only got about 3 or 4 threads on it, okay? But we made that on the lathe. And then we had to come over here and cut the slot. So sometimes I do things for people and they wonder why, you know, this costs 25, 30 bucks. Well, the reason being, it takes me time to figure out the size. It takes me time to go get the material I need if I don't have it. And then I have to make it. And then, you know, I have to, with these tiny little parts like this, it's kind of tough to work with. So what you do is you get your item turned down to the size you want, and you have to take a triangle file. See how it looks like a triangle? And you start filing a notch in it. And then when you get that notch deep enough, you take a little hacksaw, and then you cut a notch in the top, okay? And that is how you get the flat blade of the screwdriver in there. And if you did everything right, which, you know, hopefully you did, once you get your part all figured out, hopefully it'll fit. So, I'll lower this camera down. We're going to do this good old test fit. I go in this hole right here. All right, and we go. And it's threading. It's going in. See that? just like it was meant to be there. I can still cycle my bolt. I got plenty of room. Tighten it down just a hair more. Okay, so I'm going to show you the machine I made this on real quick. Walk over here. You can see this is the milling machine that I have. We did not use this to make the screw. This is like a gigantic, really fancy drill press. It can do a lot of stuff, and it's really neat. This is my lathe. This is a Grizzly, what model is it? G0709. For any of you that are interested in this kind of stuff. Okay, this is what's known as a geared head lathe. There's a gearbox here, drives the spindle, and I have different, move this out of the way. I have different chucks that I use to hold different things. We got a kind of dirty looking right now, but there's a face plate and a 4-jaw chuck right there. And here's a 3-jaw chuck. And all they do is hold stuff while I turn it. So when you're going to make a screw on a lathe, you have to know your measurements, okay? And these dials right here are measured in thousandths of an inch, so about half the size of a human hair. This one right here is the same, okay? This dial is going to move the table back and forth. This one here is going to move this tool holder. This holds my tool. Put one on there just so you can see it. It's going to move my tool at an angle in toward the chuck. And then this big wheel here moves the whole carriage assembly left and right, okay? And then I've got a handle over here that I pull, and I have to watch these numbers, and when this number comes around to a certain spot, line up that bead, I pull this lever down, and there's a set of, they call them half nuts, it's like a threaded jaw, grabs this big screw here, and it runs the table toward the chuck. Now the reason I do that is because when you're making a screw, it's not possible to freehand that and have it be repeatable, the same size, the same thread pitch every time. It's just not doable. So this right here, the machine takes over and cuts everything the same size over and over and over again. So now this thing, once it gets going, there's no stopping it. So I have to be very careful. I have to pay a lot of attention. And especially with those little tiny parts, I'm right down over there looking at it. And when you're threading toward your chuck, with your threading tool right here, it's got that little cutter. It's a little stressful. Anyways, that's the machine. Brief synopsis of the process. Finished product. So I like to share this kind of stuff with you guys because, I want to do good work for my customers. I want to make sure that they get the best quality product they can. But sometimes it is difficult to understand until you see it, why certain services that someone may offer are going to cost what they cost, especially when you can, go somewhere and buy that screw for who knows how much. But anyway, that's that. Hope y'all have a good day. Stay warm. See you next time.